Hello everyone. Today we're going to talk about partial fraction decomposition, or otherwise known as just partial fractions. That's the shorter way to call it, is just partial fractions. And so this is a Calc 2 concept that lets you handle very difficult integrals, where you're going to have like a trinomial in the denominator, and you're going to have to break that trinomial into two different fractions, so it's going to be easier to integrate. Okay, so here's the basic idea behind partial fractions. So I'm just going to give you the idea of what you're trying to look for, okay? So say you have like two fractions with two of these binomial, or just a single variable and a constant, okay? So this is just for, the heck of it. So it's just a simple 1 over 1 minus x plus 1 over x plus 1. And so what if we wanted to combine both of these fractions, okay? So basically what we would do is try to get a common denominator. So we would have to cross multiply and then, multiply both of these. So your basic idea is just multiply this by 1 minus x and then multiply this side by x plus 1. Okay, and so the denominator is going to stay the same, so we're just going to have x plus 1 times 1 minus x all over, multiplying this you get x plus 1 plus, over here it's 1 minus x. The x's cancel out and you get 2 over, and then if you were to FOIL this out, you would get x. So you'd get x and then minus x squared if you multiplied that way. And then you would get plus 1 and then you get minus x. So these x's cancel and you're left with, this is minus x plus 1. I'm just going to rewrite it so it's 1 minus x squared. Okay. And so that would be, the most simplest way if you were to combine these two different fractions of the binomials in the denominator, is that would be your most simplest form for those fractions, okay? But here's the idea of partial fractions. If you were to actually integrate this, you were to do this with everything you learned for Calc 1, you would not be able to. You can't do a U sub, there's nothing, no power rule, no algebraic manipulation, but this is where partial fractions comes in. So you can't actually integrate this. So what you have to do is you have to do the reverse. You have to go from here back to here. So you have two fractions. So that's the whole idea behind partial fractions, okay? So let's just say, for example, you were given this integral of 1 minus x squared. And so if we were to try to get this back into a fractional form, here's the basic process behind it. So you have 2 over 1 minus x squared. And so you can treat this 1 as a 1 squared, because 1 to any power is just 1. So then what you have here is a difference of squares. A difference of squares. And anything that is a difference of squares, you have an a squared minus a b squared. You would have a plus b times a minus b. That is the idea of difference of squares right there. So we're going to use this difference of squares so we can factor that out into two fractions. So we're going to have like one fraction here and then another fraction here. Now we don't know what the numerator is going to be for our fractions. So what we do here is we're going to put a letter, we're going to call it a, and then the next fraction over, if you keep adding all your fractions, it's just going to go down the alphabet. That's what we usually do, is we go a plus b and then c over this mess, and then blah blah blah. So yeah, basically that's going to be our numerator. And then if we were to do our difference of squares here, 1 squared minus x squared, that would be a1 plus b, which is x, times a, which is 1, minus b, which is x. And so those would be the two different products of that square, the difference of square here. So then you can rewrite this. Here, I'll rewrite it. So you can rewrite this whole thing as 2 over 1 plus x times 1 minus x. And then we would have our two fractions here, a plus b. And so then what we would do is we can pick the first one to go for this fraction and that one for that one. And so whatever, you know, the receding products or the factors of the whole quadratic are, you would just keep putting them under the denominator under the fraction here. So this one we would choose to be a. You could do either or. You could do 1 minus x a over 1 minus x, or you could do a over 1 plus x. It doesn't matter. You're gonna get the same result, but I'm just gonna do this one. That's what I usually like to do. So a over 1 plus x, and then b over 1 minus x. Okay. And then from here, what you look at is, I'm gonna try to get common denominators again, because that's what we did here, right? We try to get common denominators. So what I'm gonna do is just cross multiply so I can get common denominators. So I would get a times 1 minus x plus b over 1 plus x, all over, and then we would have the same denominator again. So I'm just gonna write it for the sake, but I'm gonna erase it afterwards. So this is basically what it would look like. You would have the same denominator. Oops. So basically, we have now cross multiplied so we can combine both our a's and b's. And so we can separate it. But now that the denominators are the same, we don't need to look at the denominator. All we're focused on is the numerator, because we want to know what our a and b are. So basically we have a 2 equals a 1 minus x plus b 1 plus x. So now we have a system of equations we can work with. And so the easiest way to work out a system of equations is just, so if you wanted to solve for b, then you would try to eliminate x, or try to eliminate a. If you were to solve for a, you would try to eliminate b. And so if you were to try to solve for a and you wanted to eliminate b, what you do is plug in an x value, so this whole thing goes to 0. So what x value can I plug in there? Well, I would choose x equals minus 1, so it's just 1 minus 1, which is 0, cancels b out, goes to 0, and then I would have a 1 minus a negative 1, that would be 2a. So I have 2a equals 2 on the other side of the equation. So then I would just divide by 2, and a would equal 1. So that value of a then goes into that fraction right there. Okay? I'm going to erase this real quick. And so if we wanted to solve for b, well, we would just have to do the opposite. We want to eliminate a now. So we do x equals 1, because 1 minus 1 is 0. So that would go to 0. And then we would have 1 plus 1 for b. So we would have 2b, basically, equals 2. Okay? And we divide by 2 here, and that would just equal 1 again. So you just plug in 1 for your b. Okay? So now we have both the numbers used for a and b. So basically, we just worked out, we just did the reverse process of this, which was like trying to get common denominators. So we basically got the same thing. So this becomes 1, plugging in 1 for our a, 1 over 1 plus x, plus b is 1, so it's just 1 over 1 minus x. And look at that. That is the same thing we got right here. So that is how partial fractions work, is just the reverse process of doing common denominators for fractions here. And so now we can actually integrate this. If we were to try to integrate this, 1 over 1 plus x plus 1 over 1 minus x. Well, we could do, like, we could just separate this into two different integrals, right? It's just 1 over 1 plus x, the integral of 1 over 1 plus x plus the integral of 1 over 1 minus x. So separating it, we can just do a u sub, u equals 1 plus x, du equals dx. There's little dx's here. And so, and then you would have the integral of 1 over u. Sorry, I'm running out of space. All right, I'm going to erase some of this work here. Okay. I'm going to make it bigger. Okay, so you just have the integral of 1 over u, and u is the 1 plus x. Du, you just get dx. So you just get du, and you just have to remember the integral of anything like that is just the ln absolute value of u plus c. So you would get ln absolute value of u, and we still have this other integral, so we're just going to do another u sub, u equals 1 minus x du. So you have to be careful here. So if you take the derivative of minus x, that's like minus 1 times x. And so taking the derivative of that is just minus 1. Okay, that's fine.
Can you do the dishes?
Yeah. All right, and that'll be minus du, oops, equals dx. So you just put the minus sign for that integral. So you'd have a minus integral of 1 over u du, and then that would just become minus ln of u for this one. U equals 1 minus x. And so plugging in our u's for our integral, we would get minus ln 1 plus x minus ln of 1 minus x plus c. And so that would be the answer for this integral of this 2 over 1 minus x squared. So that would be the integral, that would be the solution. And so you can actually simplify this if you want. If you know your natural log properties here. So if you have ln of a minus an ln of b, well, that's just the same as, since they have the common base here of 1, it would just be ln of a over b. So you can simplify this since they just have a common base of 1 on each side. If it was a different number, then you wouldn't be able to use this property. So you can simplify this into ln absolute value of 1 plus x all over 1 minus x plus c. And so that would also be a solution simplified. That would probably be optimal for most Calc 2 teachers to be putting it in that form. So anyways, that is partial fractions. I hope you understood it, and thank you for watching.